Hi guys, sorry to interrupt your video. Just a quick plea, subscribe to my channel please. If you haven't done it already, subscribe. Tell your friends, subscribe. Thanks. Aha, Theory Test Pro. Again, all my students gain access to it from my website. Set yourself up, other videos have got it. Now this time I'm going to go through the safety margins topic, try and help you out with that. So without much of ado, let's crack on. So, right, what lights should you use when you are driving on a wet motorway and vehicles are throwing up surface spray? Right, okay, so this comes down to the headlights on your car. We've got hazard warning lights, dipped headlights, side lights and rear fog lights. Right, let's have a look at the different types of lights. So I've gone to the RAC website because they're jolly decent chaps. Right, you've got dipped headlights. This is the first one. Most commonly used, you know when you turn your lights on at night time and people are just driving around, dipped headlights are lights that come out from the front of the car and they illuminate the road, but they're angled down, hence why they're called dipped headlights, so they don't blind oncoming traffic. Additionally, when you put your dipped headlights on, you also get the rear tail lights on, which are the red lights that you see just on the back of a car, which obviously are separate from brake lights, but just the normal one. So you get the red lights on the back and you get lights that are dipped down onto the floor. Full beam headlights, here we go. These are the ones where we floodlight the road. So you'll blind oncoming traffic, but it's great if you're going down a country lane because you'll see if you've got deer running out in front of you and things like that. Fog lights. These are underneath the headlights. So if you've got front fog lights, they're low on the car, and on the back they're just mixed in with the rest of the lights. And a fog light is a high intensity light. It's the same brightness as a brake light actually on the back. So when you put a rear fog light on, you get a bright red light at the back of the car, which is the equivalent of putting your foot on the brake. If we have a look over here, this symbol here, because the angle of the lights is flat, that's just going out dead straight, those are the back ones. And this one, because they're angled down, they would be the front ones to try and block, to stop blinding oncoming traffic. So the way a fog light works is that if you've got lots of mist in the window, like like when you've got a window and it steams up, it's difficult to see through, and if you shined a light on it, all you would get is just white reflected back. So what a fog light does is it fires under the fog so you can see through the fog and it illuminates what's behind it, so it's easier to see out. That's the idea. Whereas if you're driving in a foggy condition, you floodlight the road, the light will just bounce off the fog and come straight back in. It's really difficult to see. That's why we have fog lights. So that's the front fog light, that's the rear fog light, which is just bright red light. And you use a fog light when visibility is less than 100 meters. Poor visibility. Doesn't have to be foggy. It's when visibility is less than 100 meters, which is when the recommendation is for dipped headlights as well. Actually, you should have those on. Hazard warning lights. That's this symbol. This is the warning triangle, and that puts all of your indicator lights on all around the car. So they all flash at a constant rate. And the only time you would use that is when you have created a temporary danger or obstruction. It's not an excuse for parking on double yellow lines or going shopping. Indicators, obviously we've all seen them. You've got on the little stalk, they just indicate on the left and the right. Side lights and parking lights, same thing. Depends upon the car. Some side lights you actually put the indicator, so if I put an indicator indicated right, the right hand side indicator light bulbs would come on. Other cars, on the lighting stalk itself, when you twist the button to switch the lights on, there's a little P symbol for parking lights, and that puts just a low wattage light all around the car so that you don't wear your battery down very much. So because the rule states, or the law states, that if you park on a road with a speed limit greater than 30 miles per hour at night time, you must park with side lights on. Tail lights, they are the rear lights that you normally have on a car, and brake lights, those are the big bright lights that you get when you put your brake on. Okay, yeah, fine. And if you've got 40 brake lights, apparently you get a verbal warning, fixed penalty notice, including £60 fine. Well, there you go. Right, and you also get day running lights. Let's see if I can find one. Well, actually, that's a day running light. He's got an illuminated glow around the headlight there. They become extra bright during the day, but as soon as you turn your lights on, the car assumes that your lights are on because it's dark, and so therefore dims it down a little bit. But they are a great way of being seen during the day. Remember, we put lights on to see and be seen. Right, so which lights should you have when you're driving on a wet motorway and vehicles are throwing up surface spray? Dipped headlights. We want to be seen. Good. 2. What is the main cause of skidding? Weather, driver, road, vehicle. Right, simple. Here's a road and here's a car. Right, now that is staying put because of the amount of friction, and as I angle it, it stays put because there's still friction between my hand, but now the amount of friction wasn't enough for the amount of work gravity was asking it to do. Okay, but as long as the amount of work you're being asked to do is less than the amount of grip or friction, then it will stick to the floor, and the car is exactly the same. So even if you had bald tyres on your car and you were driving on the road, providing you weren't asking them to do very much, they will stick to the floor. But of course, you're talking about energy here. When you drive a car, when you drive down a road, when you accelerate or brake or turn, you're asking those tyres to grip the road, and the worse your tyres are, the less grip they can give up. Therefore, there's a lower tolerance on how far you can push it before they give up. And that could be purely just stuffing it into a corner at high speed. The car just goes, well, I don't grip, you know, you're asking me to do too much work, I can't grip as you want it to, and so the car slides sideways. So, to answer these questions, the weather, of course. If the roads are wet, you get less grip than in the dry. Therefore, the tolerance is lower in wet weather, ice, snow, so on and so forth, than it would be in the summertime. So yes, that is a contributing factor, but providing you stay within the tolerance, the car won't skid. It's you that is asking the car to exceed the amount of grip level that there is out there. The driver, yes, it is the driver. At the end of the day, a car just doesn't skid when it's parking there, does it? It's the driver asking it to do something, and if you exceed what it can give you, you will skid. So it's always the driver's fault. It's just the amount of work that the driver can ask the car to do varies. Dry road, new tyres, you can ask it to do a lot. Wet road, old tyres, wrong tyres, summer tyres in the winter, for instance. That's a big question. The vehicle, oh yes, of course, contributing factor. But at the end of the day, whatever you've got will grip the floor unless you ask it to do too much work. And the road, again, the road can give off varying amounts of grip, but it's still the driver that asks it to exceed it. So the main cause of a skid is always the driver. The other things contribute or change how much the driver can ask it to do. There you go. Next. What should you do when you're driving in snowy conditions? Right. This comes back to what is available. The amount of grip level that there is in snowy conditions is going to be reduced. Right, so in order to avoid skidding or accelerating, I don't ask the car to do a lot of work suddenly because I'm asking it to exceed the amount of available grip. So, in driving in snowy conditions, brake firmly and quickly? No, because if I just suddenly stop the tyres, that immediately exceeds the amount of grip and the car just slides down the road. Be ready to steer sharply? No, anything sudden will immediately exceed the amount of grip. You've got to find it, you've got to wind it on, gently brake, gently steer so that we stay within tolerances. Be ready to steer sharply? No. Use side lights only. Well, for what purpose? Okay, so you got your lights on. Personally, if it's a bit rubbish, if snowy condition, I have dipped headlights on rather than just side lights. Brake gently in plenty of time. Absolutely. Brake gently over a long distance, therefore you've got time to work out how much grip levels there are, and you don't have to ask it to suddenly stop. You haven't run out of road, you've still got loads of time. It's always better to start braking early and go, oops, I've got more grip than I thought. I'll stop a bit early and just drive a second bit and then stop again, than run out of road and ask the car to do more than it can give you. Right, what is the main benefits of driving a four-wheel drive vehicle? Right, so what we've got: improved grip on the road, lower fuel consumption. No, it's often the other way around, you get worse fuel consumption. Shorter stopping distances. Interestingly, no. Improved passenger comfort. Doesn't make any difference. It's improved grip on the road. Now, the reason for this is cars are two-wheel drive, four-wheel drive. You can get front-wheel drive, which means when you accelerate, all the power goes through the front wheels and then the front wheels pull the car down the road. You can get rear-wheel drive, where the power goes to the back wheels, so they push your car down the road. Gives you better acceleration generally. If you think about it, if you were going to move a car, you'd get behind it and push, wouldn't you? Because as you push, that weight of the car pushes your feet into the floor, so you get more traction, and so therefore it's easier to move the car. If you stood in front, you've got to try and almost lift the car to get it going. So it's much harder to pull a car than it is to push a car. But if you had four-wheel drive, then you could pull and push, so you get extra work spread over, so therefore it's easier to move the car straight off. So improved grip on the road. Yeah, you're less likely to get wheel spin because you've got four wheels trying to move you rather than just two. So that's better. But interestingly, when it comes to braking, the braking system on all cars is pretty much the same. So what you often find is that in snowy conditions, for instance, four-wheel drive systems will enable you to drive down a road further than a two-wheel drive car will, because often a two-wheel drive car just can't get down there. The wheels are spinning and the car gets stuck at the entrance. A four-wheel drive will continue down a road, down into this wilderness, but as soon as you get to a hill, because the brakes are all the same, whenever you put the foot on the brake pedal, all cars brake the same way, so they all slide down the hill and smash into a lamppost. So that's a little bit misleading, that question, because what it's saying is improved grip on the road. No, it gives you improved grip when moving off, but you don't get any extra grip when you're stopping. That's to do with the type of tyre that you have fitted to your car, and that could be applied to any car. So a four-wheel drive system is great in slippery conditions to get moving, but it could well find yourself wrapping yourself around a tree, so because you can get further into trouble before the car lets go. That's the